Betelgeuse, one of the most famous stars in the night sky, has long captured the attention of astronomers and stargazers alike. Its distinct reddish hue and enormous size make it a standout feature in the constellation Orion, easily visible from Earth with the naked eye. Recently, though, Betelgeuse has become the center of attention for a different reason, one that has excited the scientific community: a sudden and dramatic 250% increase in its brightness, as observed by the James Webb Space Telescope. This unexpected development has raised intriguing questions about the star's current activity and future fate. Betelgeuse is a red supergiant, a type of star in the final stages of its life cycle. Located around 642 light-years away from Earth, it is one of the largest and brightest stars in the Milky Way, about 700 times the size of the Sun and over 10,000 times more luminous. These stars are known for their instability as they near the end of their lives, and Betelgeuse has been no exception, showing erratic dimming and brightening cycles over the years. However, this most recent and dramatic brightening is unlike anything astronomers have ever observed, marking a significant event in the field of astrophysics. The James Webb Space Telescope, equipped with advanced infrared capabilities, played a critical role in detecting this sudden change. By peering through the thick layers of dust and gas surrounding Betelgeuse, JWST provided scientists with a clearer view of the star's surface and its surroundings. What it discovered was astonishing. Betelgeuse's brightness had increased by an incredible 250% within just a few weeks, a rapid and unexpected change that suggested something unusual was happening within the star. The implications of this sudden brightening are profound. For years, Betelgeuse has been a candidate for a supernova, a massive explosion that occurs when a supergiant star runs out of nuclear fuel. While this explosion is predicted to happen sometime within the next 100,000 years, this new surge of energy raises the question of whether that moment could be approaching sooner than expected. The star's erratic behavior in recent years, coupled with this latest brightening, indicates that Betelgeuse may be entering a more unstable phase, one that could precede a catastrophic supernova. If Betelgeuse were to explode, it would be an astronomical spectacle visible from Earth even during daylight, outshining the full moon for several weeks. However, despite the star's relative proximity, such an event would not pose any danger to life on Earth due to the vast distance separating us. Instead, it would present a unique, once-in-a-lifetime opportunity for scientists to observe a supernova in real time, offering invaluable insights into the processes that govern the end of massive stars. The recent brightening of Betelgeuse also raises new questions about the inner workings of red supergiants. These stars are notoriously unpredictable due to their immense size and complex internal dynamics, which create turbulent conditions that challenge even the most advanced models. Betelgeuse, in particular, has puzzled astronomers for years with its irregular light patterns. Understanding why its brightness has suddenly increased by 250% could shed light on the life cycles of red supergiants and the mechanisms behind their fluctuations. One theory emerging in response to this event is that Betelgeuse may have undergone a massive convective cell or hot gas bubble, rising from its core to the surface. Such convective events are common in supergiant stars and can lead to significant changes in brightness as material is ejected from the star's outer layers. If Betelgeuse experienced such a convective event, it could explain the rapid increase in its luminosity, as the release of hot gas into space would temporarily brighten the star. Another possibility is that Betelgeuse has shed a large amount of mass in the form of a stellar eruption, creating a cloud of dust and gas that could be interacting with the star's light. In 2019, Betelgeuse experienced a mysterious dimming event, which some scientists believe was caused by a large cloud of dust obscuring part of the star. This recent brightening could be a reversal of the previous dimming event, with new material being expelled and illuminated by the star's intense light. Another fascinating theory is that Betelgeuse's magnetic field might be influencing these changes. While its magnetic activity is not well understood, Recent studies suggest that the star may have a complex and dynamic magnetic field that could impact its brightness. Shifts in the magnetic field could alter how energy moves through the star, leading to rapid fluctuations in its luminosity. If this is the case, the current surge in brightness might be linked to a shift in Betelgeuse's magnetic activity, offering scientists a new avenue for exploring stellar magnetism. As astronomers continue to observe Betelgeuse, the sudden increase in brightness also brings attention to the role of stellar mass loss in the evolution of supergiant stars. Red supergiants like Betelgeuse lose mass at an extraordinary rate, ejecting large amounts of gas and dust into space. This mass loss is believed to be crucial in the final stages of a star's life, as it can impact the star's structure and stability. If Betelgeuse is indeed losing mass at an accelerated pace, it could indicate that the star is nearing a critical point in its life cycle, potentially leading to more instability, and eventually, a supernova. This event is also timely for the field of astrophysics. As the James Webb Space Telescope continues to transform our understanding of the universe, JWST's ability to detect infrared light has opened new doors for studying distant and obscured celestial objects. Betelgeuse's sudden brightening presents a perfect target for its cutting-edge instruments, allowing scientists to capture detailed images and data. Currently, the JWST offers scientists a unique opportunity to study the complex behavior of a red supergiant on the verge of transformation. While there is excitement around Betelgeuse's potential to become a supernova, it's important to note that this recent increase in brightness doesn't necessarily signal an imminent explosion. Red supergiants are notorious for their unpredictable behavior, and Betelgeuse could simply be experiencing one of its many phases of instability. However, the extraordinary 250% increase in brightness suggests that something significant is happening within the star. As astronomers investigate the cause of Betelgeuse's sudden brightening, this event underscores the dynamic and often chaotic nature of stellar evolution. Stars like Betelgeuse, in the final stages of their lives, are influenced by a range of internal and external forces that can dramatically alter their appearance and behavior. Understanding these processes is crucial, not only for predicting the future of stars like Betelgeuse but also for gaining insight into the broader mechanisms that govern the life and death of stars across the universe. Betelgeuse's sudden brightening serves as a reminder of the powerful and unpredictable forces at work in the cosmos. Stars are not static objects. They are dynamic systems that evolve and change over time. Betelgeuse, with its rapid fluctuations in brightness, provides a valuable glimpse into the complex and often violent processes that drive stellar evolution. As scientists continue to study this remarkable star, they are likely to uncover new insights into the forces that shape the universe. One of the most exciting aspects of this discovery is the potential for future observations. Betelgeuse is now being monitored closely by a range of telescopes and instruments, including JWST and ground-based observatories. These observations will allow scientists to track the star's behavior in real time, offering valuable data that could help explain the underlying causes of its sudden brightening. In the coming months and years, astronomers will be watching to see whether Betelgeuse's brightness continues to fluctuate or returns to its previous levels. The implications of this event extend beyond Betelgeuse itself. Red supergiants are a common type of star in the universe, and studying Betelgeuse's behavior could offer valuable insights into the life cycles of other massive stars. By understanding the processes driving Betelgeuse's brightness fluctuations, scientists can apply these lessons to other stars, helping to build a more complete picture of how supergiants evolve and die. This knowledge could also shed light on the formation of supernovae, black holes, and other exotic objects that play a critical role in the universe's evolution. In addition to its scientific importance, Betelgeuse's sudden brightening has captured the public's imagination, reminding us of the universe's wonders and the mysteries yet to be solved. Betelgeuse has long been a star steeped in legend and mythology, associated with the figure of the hunter Orion. In many cultures, its dramatic and unpredictable behavior only adds to its allure, continuing to inspire curiosity and awe in both scientists and the general public. The recent surge in Betelgeuse's brightness is not just an astronomical oddity but a testament to the ever-evolving nature of the cosmos. Once thought to be somewhat predictable in its variability, Betelgeuse has now provided a striking reminder of how much there is still to learn about the life cycles of massive stars. The 250% increase in luminosity detected by the James Webb Space Telescope has sent ripples through the scientific community, raising new questions about the internal workings of such massive celestial bodies and their eventual fate. To fully grasp the implications of this event, it's essential to explore not only the scientific and technical aspects but also the broader cosmic and philosophical questions it poses. Betelgeuse, a red supergiant nearing the end of its life, has always been a fascinating subject of study due to its irregular and peculiar behavior. However, this unprecedented increase in brightness has forced scientists to reconsider established models of stellar evolution, particularly for supergiants. The sudden surge raises fundamental questions about the forces at play within Betelgeuse that could trigger such a dramatic change. Like many large celestial bodies, Betelgeuse is governed by complex interactions between gravity, fusion processes, and magnetic fields, all of which may be contributing to its recent outburst of luminosity. One area where this event could provide crucial insights is in the study of stellar fusion. At the core of every star, including Betelgeuse, nuclear fusion generates the energy needed to counterbalance the force of gravity pulling the star inward. In a supergiant like Betelgeuse, these fusion reactions are more intricate than those in smaller stars, such as our Sun, as the extreme temperatures and pressures allow for the fusion of heavier elements beyond hydrogen and helium. As red supergiants approach the end of their lives, these fusion processes become increasingly unstable, with the star struggling to fuse heavier and heavier elements. Eventually, it reaches a point where it can no longer generate enough energy to resist the force of gravity, setting the stage for its ultimate collapse and potentially a supernova explosion. This latest brightening event offers a rare opportunity to gain a deeper understanding of these final, tumultuous stages of a massive star's life. The 250% increase in Betelgeuse's brightness could signal a significant change in its fusion processes, potentially involving the fusion of heavier elements in the star's core. As it depletes its fuel, the core contracts, causing the outer layers to respond dramatically to the internal changes. This reaction could result in large-scale ejections of material, temporarily increasing the star's brightness. In this sense, the recent brightening might be a precursor to more violent internal convulsions, bringing Betelgeuse closer to its eventual fate as a supernova. However, this increase in brightness is not just a sign of an imminent explosion. It also highlights the often overlooked phenomenon of mass loss in supergiant stars. Like other stars at this stage, Betelgeuse has been steadily shedding mass over time through stellar winds and outbursts. The gas and dust ejected form intricate clouds around the star, which can either dim or enhance its light depending on how the material interacts with the star's emitted light. In conclusion, Betelgeuse's recent brightening has provided astronomers with a rare glimpse into the complex and dynamic processes happening inside a red supergiant nearing the end of its life. While we still don't know exactly what will happen next, this extraordinary event has deepened our understanding of stellar evolution and the dramatic changes stars like Betelgeuse can undergo. Whether this surge in brightness is a sign of its eventual supernova or just another phase in its unpredictable life, it serves as a powerful reminder of the mysteries still hidden in the cosmos. What other surprises might Betelgeuse have in store for us? Could we be on the brink of witnessing a supernova in our lifetime? I'll be reading you in the comments box. If you like the video, press the like button and subscribe so you don't miss our next videos.